All right, so let's try this one. First of all, I'm going to think about my graph. And this is x squared plus 1, so I know from 0 to 4 that I'm going to start at 1 and come up. This point here, when I plug in 4, I'm going to get 17. So my area is going to be all of this bit here. Well, I know that that's going to include a rectangle underneath that has a 1 by 4. So certainly my area is greater than 4. I could also think about this area. This area is going to be 4 by 16. And so I know that I'm going to be less than whatever 4 by 16 is. So, and even less than half of that. So I can think about my values. So if I'm letting my n go to infinity, that means my width of all my individual rectangles is going to 0. So I'm going to take the integral from 0 to 4 of x squared plus 1 dx. So dx is letting my n go to infinity. I'm getting this to approach 0. 1/3 x cubed plus x. No c because I'm evaluating from 0 to 4. And then I'm going to subtract off substituting 0. Well, that's just 0. So I'm going to get 64 over 3 plus 12 over 3. And 76/3 are my units. I can also evaluate this on my calculator. My calculator will evaluate definite integrals for me. So we'll go ahead and look at this one while that loads. Oh, all right. So you can see I've done one here. The way that I get there, alpha window, fn int. This time I'm going from 0 to 4. My function was x squared plus 1 dx. 25 over 3. We had an answer of 76/3. And sorry, not 25 over 3, 25.3 repeating. Same answer. So let's try this one. Now we're going from 1 to 2. So 1 to 2, my f of x is x cubed dx. If I think about this graph, I've got this shape here, but I'm going from 1 to 2, and now my subtraction makes sense, because if I just plug in the 2, it's like I'm looking for going from 0 to 2. So when I plug in my 2 to the 4th, this area really is like going from 0 to 2, but I want to subtract off this bit from 0 to 1. So this is going to end up being 4 minus 1/4 is 15/4 as my total area.